Visual programming environments are designed specifically to support children in learning computational thinking and how to start programming. There are many different environments that have been produced to aid learning how to program, including Scratch, Blockly, Mindstorm Robots, and many more. Some of these environments are online environments where students program using a web-based interface. Others can be downloaded as apps, while others are robotics-based and can be either programmed using a direct interface like a remote control or by using a visual programming language. What makes a programming language visual? Visual programming languages are not really text-based like industry standard programming languages, where a text editor is used to write a program. Visual programs are often made by composing together a series of visual blocks, where each block represents a different instruction. You can see some examples here of visual blocks for the Scratch programming language. As these are visual programming environments and designed for children, the programs are often based around simple games such as visual mazes or around characters who might have adventures or might be programmed to do a dance. As such, we need to have instructions that involve movement, changing colors and positions, as well as the more traditional instructions to control decisions, such as if statements, and loops, such as the repeat loop instruction shown here. What is interesting about this repeat loop block is that it has a value that can be set when you add the block to your program. This value controls how many times the loop is executed, in this case 10 times. In this lesson, we want to provide an overview of some of the visual programming environments that you might find useful, and to discuss their key features. We will explore two of these environments, Blockly and Scratch, in more detail through worked examples. The first system we will look at is RoboBoogie, which is a great learning environment for helping explore data and variables within programming. In this example, we show how the robot dance is changed by changing the values associated with how much each arm will move, or how much its hips will move, or how its head will move during the dance. This is initially done using sliders. However, you can change the view in the learning environment so that it actually shows the different variables that are associated with each of these values, such as the angle of rotation of the arm, the starting position of the leg, etc. This is a great interactive activity that can be easily connected with mathematics as well as programming. The next system we will look at is Blockly, which is a very useful visual programming environment for learning programming and fundamental computational thinking skills. Blockly has several existing activities online that you can use straight away in the classroom, including this one where students have to develop algorithms to solve a series of maze puzzles. In this first maze, we have to solve the problem by connecting a series of blocks that represent different instructions for our algorithm. We are able to choose from 3 instructions: move forward, turn left, and turn right. We can see how we are able to combine instructions, in this first case, combining multiple instances of moving forward to solve the maze. In the next example, we can see that we need to combine different instructions. And in the next example, we can see how we have made this puzzle more complicated by putting a restriction on the number of instructions we are able to use. But we can use the repeat loop to repeat a single instruction multiple times and achieve our aim. In this last example, we can see how we have a much more complicated maze, but we can also identify that it is very similar to a problem that we have solved previously. This is a good example of pattern recognition, which is a crucial skill in computational thinking, and helps us identify subtasks for decomposition, and how we can use repetition to solve problems more efficiently. In later years, this system, Scratch, might be a good system to explore programming with. Scratch is very similar to Blockly in that it is block-based, but it has a wide variety of blocks that can be used to explore programming. Scratch is based around programming the behavior of characters which respond to events, such as you pressing a button or entering a value in response to a question. Scratch can be used to create quite interesting games and activities. We will look at the system in more detail in a later lesson. I hope that this has provided a useful overview of the kinds of programming environments that are available for education. We will explore some of these in more detail throughout the next lessons. Visual programming environments have received a lot of attention over recent years with the increase in focus on developing early computational thinking skills. Because of that, there are many resources available on the internet to help teachers develop activities and learn how to use these different environments. In this module, we will be showing you some of the existing resources so that you can locate good source points for future activities that you would like assistance with. We will also provide an additional set of resource links for other programming environments and places online where you can go for help in learning how to program using these kinds of systems.